In this video we are going to talk about how hard water can be softened, and we've already talked about what hard water is and how it collects calcium and magnesium ions as it travels over certain types of rock. And we said that if we had some water that was hard and we magnified a small part of it and had a look inside, we would see, if we were able to see that much into it, we'd be able to see magnesium and calcium ions that were in the water, and these cause the water to be hard, and they caused various problems in terms of forming something that we called scum and also something that we called scale that affected appliances. But what we're going to look at now is ways that we can soften hard water. There are two ways which we need to know about, and the first one is by adding a substance called washing soda. Now the chemical name for washing soda is sodium carbonate, and what we have is a way to soften hard water. Now what happens is we have calcium ions that are in the hard water. We have then something called carbonate ions which are in the sodium carbonate, so that's where they come from, and when they combine together with the calcium, you can imagine, if you think ahead a little bit, that they make calcium carbonate. The other one product is the sodium ions, and they will stay in the water, in the solution. We might want to add here a little A and a Q to mean aqueous, which means in solution, and here as well. This is a precipitate, or it's a solid that is produced from the two ions that are in the water, and this is the scale that we talk about sometimes. And this is a simpler way of actually softening water, or not a simpler way, but a less energy expensive way. So it takes less energy to remove the hardness of the water as compared to heating it, as we talked about in the previous video. Now you could actually look at what happens with the magnesium ions as well. So if you wanted to, you could use this as a basis, as an outline, and have a go at what the equation would look like with the magnesium. But if not, it's there. So we have magnesium ions, same way we have the carbonate from the sodium carbonate, and we have magnesium carbonate and the sodium ions again in the solution. So that's one way of doing that. I suppose I should write out the words here so that you are able to remember those. There you go, that's just to help you to remember what those different parts mean. The second way is to use what we call an ion exchange column, and the way an ion exchange column works is it's a little cylinder that's packed full of a substance called a resin. A resin is like a type of a plastic or a type of a polymer, but in that resin we have sodium or hydrogen ions. So if we were to look a little more closely at what was going on, I've just tried to magnify it a bit here. It looks a little bit confusing, but here are in red are calcium ions, the purple color are the magnesium ions that are causing the water to be hard, and the green here are the sodium ions that are found in the resin. And if we look just a little bit closer still, so it's not so confusing, here are the beads of the resin with the sodium ions in there, and what we have is an exchange of the sodium with the magnesium and or the calcium. So the magnesium and the calcium are exchanged with the sodium. The water is left with some sodium ions in it, but the magnesium and calcium has been removed. We can think of it similarly with hydrogen ions. Sometimes the resin contains hydrogen ions, and again these two are exchanged or swapped with the hydrogen ions in the resin. And so what you're left with is water coming out of the other end of the ion exchange column that has been softened, that has had the magnesium ions and the calcium ions removed. Now sometimes we run out of sodium in our resin. And what we have to do is to recharge it, and we can just do that with sodium chloride, and sodium chloride is a salt solution. So that's why a lot of dishwashers, things like that, need to have or water softeners need to have sodium chloride in there, or need salt in there in order to replenish these resins. The last thing then here is just commercial water and a soft water softener. These are the details of how it works. They contain resins with hydrogen ions or sodium ions in the resin, and the hydrogen or sodium ions are exchanged or swapped with the calcium and magnesium ions. So that's just a summary of how it works. These are the diagrams to actually explain to you or show you how that works. The last thing I want to go through is for the higher tier only. So if you're doing the higher tier, you do need to know about this, and this is how hard water is actually softened, or temporary hard water is softened when you heat it. So the first thing to remember is that temporary hard water contains what we call hydrogen carbonate ions, hydrogen carbonate ions, and it's written like this: HCO3 with a little charge of a 2 minus. So we have our hydrogen carbonate ions. This, when heated, decomposes into carbonate ions, as we saw before, and these carbonate ions can then react with our magnesium ions or calcium ions that are found in the hard water, and that leaves us with either magnesium carbonate with the magnesium ions or calcium carbonate with the calcium ions in the water. And you should be able to explain this process and actually know how this happens. Now, you might also be presented with another way of showing it. This is actually the process broken down into 2 steps using the equations. This one here I don't think is balanced. I think that makes it correct. Right, so the first step is it's just the same as what I've done over here. The first step is we've got the hydrogen carbonate ions, which are decomposed into our carbonate ions. I didn't mention over here, but we also have water and a little bit of CO2 produced as well. But here we have our carbonate ions, and if you look here, we have the calcium ions in the water. They combine with the carbonate ions, and we then have our calcium carbonate. We could do a similar thing with the magnesium as well, using this as a guide, but this is what we have as our scale. This is the stuff that builds up on our heating elements in our kettles and so on. Now, this is a way that we can soften hard water, but if we were trying to do this on a large scale, or even if it was to supply a house, doing this would be very expensive because we require heat energy in order to heat it for this to happen. Remember, this only works with temporary hard water. Permanent hard water can't be softened in this way. However, we can use the methods described previously to soften permanent hard water. Okay, so that's basically the methods you need to know about for softening hard water. That's me done for this video. Thank you for watching, and I'll see you again soon.